A mine shaft in the Yukon in 1898 was not just a hole in the ground. It was a masterpiece of microengineering, a vertical fortress plunged deep into a subterranean world of frozen rock and gravel. The timber cribs that lined these shafts were not primitive log arrangements. They were sophisticated structural systems designed with a precise understanding of physics, thermodynamics, and materials science. The men who built them were not just desperate gold seekers. They were engineers of necessity, battling a foe as formidable as any on Earth, the permafrost. They understood that to pull gold from the ground, they first had to conquer the ice. They learned to transform the very trees growing on the frozen surface into a rigid, load-bearing skeleton that could hold back the immense pressure of the earth, a structure capable of descending hundreds of feet into a substance as hard as concrete. This was not luck. This was not brute force. This was a forgotten science, born in the crucible of the Klondike, where a single miscalculation in the geometry of a log frame meant being crushed to death in the dark. My name is Sam, and this is Wild America. Part 1. The Tyranny of the Ice, the central challenge of the Klondike, the one that broke men and defied their best efforts, was not the staggering cold that could freeze a man's breath in his beard, the profound isolation of the vast, silent wilderness, or the back-breaking labor that wore men down to skeletons. It was the ground itself. The gold wasn't lying in the creek beds waiting to be scooped up. The vast majority of it, the fine dust and heavy nuggets that had been eroding from the mountains for eons, had settled onto the bedrock, buried under 30, 50, sometimes over 100 feet of what the miners called muck. This was a geological anomaly, a frozen slurry of gravel, soil, peat, and solid ice lenses, some as thick as a man's arm. This was the permafrost, a layer of permanently frozen ground that had remained locked in a state of absolute zero for thousands of years, a relic of the last ice age. Ernest Patty, a mining engineer who cut his teeth in the North and later became president of the University of Alaska, described the challenge with chilling accuracy. The gravel was permanently frozen, and this permafrost was as resistant to excavation as a mass of reinforced concrete would be. A pickaxe, the iconic tool of the prospector, was useless. It would bounce off the iron-hard surface with a metallic clang, the impact barely scratching it. To the tens of thousands of stampeders who arrived in 1897 and 1898, filled with dreams of golden riches, this was a geological and psychological nightmare. They had come for gold, but found themselves facing a seemingly impenetrable wall of ice. The miners quickly realized that surface mining was impossible. The only way to reach the pay streak on bedrock was to go straight down. This meant sinking a vertical shaft, a perfectly cylindrical hole, through the entire depth of the permafrost. But how do you dig a hole in something you can't break? The answer, in the early desperate days of the rush, was as primitive as it was deadly. Fire. Part 2. Descent into the inferno. The first technique the miners developed was called fire setting. It was a brutal, inefficient, and incredibly dangerous process that had been used in hard rock mining for centuries, but never in conditions like these. At the end of a long day of clearing the surface, a team would build a large, roaring fire at the bottom of their shallow, nascent shaft. They would let it burn all night, the intense heat penetrating the frozen ground. By morning, the fire would have thawed a layer of muck approximately 12 to 14 inches deep. The miners would then descend into the smoky, gas-filled hole. The air was thick with the acrid smell of burnt wood and damp earth, and a constant noxious haze stung their eyes and choked their lungs. They would shovel the thawed, muddy gravel into a heavy bucket, which was then hauled to the surface, often using a simple hand-cranked windlass. This device, a horizontal drum mounted on a crude wooden frame, required 2 men to turn the handles, slowly and painstakingly hoisting the 100-pound load foot by foot from the depths. Then they would repeat the process, night after night, descending deeper into the earth 1 foot at a time. It was a slow, torturous, and claustrophobic existence. The shafts, typically measuring about 3 feet by 6 feet, were tight, dark, and damp. The fires consumed the oxygen and filled the narrow columns with smoke and, far worse, carbon monoxide, a colorless, odorless gas that could kill a man in minutes. Ventilation was a constant life-or-death concern. In the brutal Yukon winter, a natural phenomenon helped. The extreme cold air at the surface, being denser, would sink into the shaft, displacing the warmer, toxic air and creating a slow, life-saving circulation. But it was an imperfect and unreliable system. Many miners, working alone or too exhausted to notice the telltale signs of poisoning, headache, dizziness, nausea, would simply fall asleep at the bottom of their shafts and never wake up. The shaft became their tomb. Yet the permafrost, the miner's greatest enemy, also provided a strange and vital advantage. Because the walls of the shaft were frozen solid, they were self-supporting. Unlike in mines in warmer climates where the earth is loose and prone to collapse, the frozen ground held its own shape, a perfect, rigid cylinder of ice and rock. This allowed the miners to sink their shafts without the constant fear of cave-ins, at least for a time. The real engineering challenge began when they reached the bottom and started to tunnel horizontally, chasing the gold. Part 3. The birth of the steam point. The slow, smoky agony of fire setting dominated the first year of the gold rush. It was a method born of desperation, and it was holding the miners back, but in 1898, an accidental discovery by a miner named Clarence Berry, one of the Klondike's first millionaires, would change everything. Berry was using a steam-powered hoist to haul logs on his claim. He noticed that a jet of excess steam, hissing from an exhaust hose, had effortlessly melted a deep hole in a pile of frozen gravel. A light bulb went on. What if that steam could be aimed? What if it could be weaponized against the permafrost? The invention of the steam point was a technological revolution that spread through the goldfields like wildfire. The concept was simple but brilliant. A steam boiler, typically a 40-horsepower locomotive-type model weighing over 8,000 pounds, would be connected via rubberized hoses to a series of long, hollow steel pipes. These pipes, the steam points, were usually 10 feet long, made of extra heavy steel, and tipped with a sharp, welded chisel bit. Miners would hammer these points deep into the frozen ground. When the high-pressure steam was released, it would surge through the pipes and blast into the permafrost, melting it with incredible speed and efficiency. Suddenly, the 14-inch per night progress of fire setting was a distant memory. A single miner with a steam point could thaw several cubic yards of gravel in a single shift. The technology was a game changer. With no proper hydraulic pipe available in the early days, ingenious miners improvised, welding old rifle barrels together end to end to create their steam points. They could now sink shafts faster, deeper, and more safely than ever before, free from the constant threat of carbon monoxide poisoning. The steam boilers themselves became a common sight on the claims, their chimneys belching smoke day and night, their operators constantly feeding them with cordwood to maintain pressure. But this new speed created a new and equally dangerous problem. As miners reached bedrock and began to tunnel horizontally, following the pay streak in what was known as drift mining, they were thawing large underground chambers. The self-supporting nature of the frozen ground was gone. The ceilings of these drifts, now dripping with water and losing their structural integrity, were prone to sudden, catastrophic collapse. The miners needed a way to hold back the immense weight of the thawing earth above them. They needed an internal skeleton for their mine. They needed the timber crib. Part 4. The architecture of the crib. A timber crib was a deceptively simple, yet brilliantly effective, support structure. It was, in essence, a hollow, log cabin-style tower built from the floor of the drift up to the ceiling. Miners would start by laying 2 parallel timbers on the floor, ensuring they were level and properly positioned. They would then place another 2 timbers perpendicularly on top of them, creating a square or rectangular frame. They would continue stacking these layers, alternating the direction of the timbers until the structure reached the ceiling. The final layer was wedged tightly into place with wooden shims, transferring the load of the roof directly down through the timber frame and into the solid ground below. The genius of the crib was its ability to handle immense pressure through controlled compression. The timbers, typically rough-hewn spruce logs measuring at least 6 inches by 6 inches in cross-section, were incredibly strong under vertical load. The open, box-like structure was designed to yield slightly under pressure, groaning and shifting to give audible warning of increasing roof stress, unlike a rigid post which could snap without warning. To increase their stability, the hollow center of the cribs was often filled with waste rock and gravel, creating a solid, load-bearing pillar capable of supporting up to 200 tons. This fill also prevented the timbers from buckling inward under extreme lateral pressure. These were not just random piles of logs. The construction was precise, following principles that miners had learned through hard experience. The aspect ratio, the ratio of height to width, was critical. A crib that was too tall and narrow was prone to buckling and collapse. Miners understood this intuitively, keeping their cribs wide and stable, with a height-to-width ratio rarely exceeding 2 to 1. The contact area between the timbers was also a key factor. A wider timber distributed the load more effectively, reducing the crushing stress on the wood fibers. In the larger drifts, multiple cribs would be built, spaced anywhere from 5 to 10 feet apart, creating a veritable forest of support columns holding up the roof of the mine. The spacing was calculated based on the estimated weight of the overburden and the strength of the remaining frozen ground between the cribs. Part 5. Sourcing the fortress. Of course, building these subterranean fortresses required a massive and continuous supply of timber. In the desolate, frozen landscape of the Yukon, where trees were sparse and often stunted by the harsh climate and thin soil, lumber became a commodity as precious as gold itself. Joseph Ledoux, the canny founder of Dawson City, understood this from day one. Before the first wave of stampeders even arrived, he had dismantled a sawmill at his old trading post and shipped it downriver to the new town site. He knew that the real money wasn't just in finding gold, but in supplying the men who were looking for it. His sawmill, powered by a steam engine, could process thousands of board feet per day, turning the spruce logs floated down the Yukon River into the rough lumber that the miners desperately needed. By 1898, the price of lumber in Dawson City had skyrocketed to levels that would be unimaginable anywhere else. Rough-sawn spruce, the primary wood used for cribbing, sold for an astronomical $150 per 1,000 board feet. For context, that same amount of lumber in Seattle might have cost a few dollars. The cost of hauling the lumber from the sawmills in Dawson to the distant claims on Bonanza or El Dorado creeks could be even more expensive than the wood itself. One report from the era stated that hauling alone could cost $100 per 1,000 board feet. The trails were rough, the distances were long, and the work was backbreaking. A single mining operation could easily spend thousands of dollars, tens of thousands in today's money, on timber just to secure its underground workings for a single season. Wages for skilled timbermen were equally high. A good man who knew how to frame a shaft and build a stable crib could command $15 a day, an enormous sum at a time when a laborer in the United States might earn $1 or $2 for the same work. These men were worth every penny. A skilled timberman could read the ground, anticipate problems, and build cribs that would stand for decades. The mine owners paid these prices without hesitation. They knew that the cost of timber, no matter how inflated, was an investment in their own survival. A poorly built crib was a death sentence, and in the dark, frozen tunnels deep beneath the Yukon, there were no second chances. Part 6. The Underground City. As the miners followed the pay streaks, they created a vast, unseen world beneath the frozen creeks. A single claim could have hundreds of feet of horizontal drifts branching off from the main shaft, creating a complex, subterranean maze. This was drift mining, a dark, wet, and dangerous business. The steam points, while effective, created a constant dripping rain of meltwater, and the air was always thick with the smell of damp earth and rotting timber. The only light came from candles or the flickering, smoky flames of seal oil lamps, which cast long, dancing shadows on the icy walls. The temperature in the drifts hovered just above freezing, cold enough to chill a man to the bone, but warm enough to keep the thawed ground from refreezing. In this underground city, the timber cribs were the only thing standing between the miners and tons of unstable, thawing ground. They were the pillars of this hidden world. As one drift was worked out, the miners would begin another, leaving the old tunnels to slowly collapse behind them. The work was relentless, a constant cycle of thawing, digging, and timbering. They were not just digging for gold. They were actively creating and managing an underground environment, fighting a constant battle against the encroaching ice and gravity. The sound of creaking timber was a constant companion, a reminder that the earth above was always pressing down, always seeking to reclaim the space that had been carved from it. This network of tunnels represented an incredible investment of time, labor, and capital. Each foot of drift had to be won from the permafrost, and each foot had to be secured with expensive timber. The miners became experts in this specialized form of engineering, learning to read the sounds of the shifting ground, to judge the stability of the roof, and to place their cribs with maximum efficiency. Their lives depended on it. A collapse could bury a man alive, trapping him in the dark with no hope of rescue. Part 7. The Dangers Below. Working in the drifts was not just physically demanding, it was psychologically crushing. The constant darkness, the isolation, the ever-present danger of collapse, all of it wore on a man's mind. Some miners developed a condition known as drift fever, a form of claustrophobia that made it impossible for them to continue working underground. Others simply pushed through, driven by the promise of gold and the need to survive. The work was done in shifts, with teams rotating in and out of the mine to maximize productivity. A typical shift might last 8 to 10 hours, during which a miner would thaw gravel, shovel it into buckets, and haul it to the base of the shaft, all while constantly monitoring the stability of the roof and walls. The dangers were not limited to cave-ins. The thawing process itself created hazards. As the permafrost melted, it released pockets of methane gas that had been trapped for millennia. This gas, if ignited by a candle or lamp, could cause a deadly explosion. Miners learned to watch for the telltale signs of gas, a flickering flame, a sweet smell in the air, and to ventilate their workings carefully. Water was another constant threat. As the ground thawed, water would seep into the drifts, pooling on the floor and making the footing treacherous. In the worst cases, a drift could flood completely, drowning anyone who couldn't escape in time. Despite these dangers, the miners pressed on. They had come too far, invested too much to turn back now. The gold was there, just a few feet away, and they would do whatever it took to reach it. The timber cribs, those simple structures of stacked logs, were their lifeline, the only thing standing between them and disaster. Part 8. The Winter Campaign. The entire process of drift mining was a race against the seasons, a campaign fought in the dead of winter. The miners chose to sink their shafts and dig their drifts during the coldest months for a simple yet critical reason. The cold was their ally. The sub-zero temperatures kept the unthawed portions of the mine frozen solid, preventing water from seeping in and flooding the workings. It was a delicate balance, a dance between fire and ice. They used steam to thaw the precise section of gravel they wanted to excavate, while relying on the surrounding permafrost to act as a natural, impermeable barrier. The pay dirt they excavated was not processed immediately. In the winter, all the water was frozen solid, making it impossible to run a sluice. So the miners would haul the gold-rich gravel to the surface and pile it into massive dumps. These dumps could contain thousands of tons of earth, the entire winter's output of a mine. The gold was safe there, hidden within the frozen mass of rock and dirt, impossible for a thief to process. These dumps, growing larger with each passing week, were a visible symbol of a miner's hard work and potential wealth, a frozen bank account waiting for the spring thaw. When spring arrived and the creeks began to flow again, the second phase of the operation began. The miners would build long wooden sluice boxes, troughs with riffles along the bottom, designed to catch the heavy gold particles. They would shovel the pay dirt from the dumps into the sluices, and the running water would wash away the lighter sand and gravel, leaving the heavy gold flakes and nuggets trapped in the riffles. It was only then, after months of dark, dangerous work underground, that the miners would finally see the fruits of their labor, the glittering reward for their winter campaign against the ice. Some would strike it rich, pulling out thousands of dollars worth of gold from a single season's work. Others would find nothing, their dumps yielding only a few dollars per ton, not enough to cover their expenses. Part 9. A Legacy in the Ice. Today, the Great Klondike Gold Rush is a distant memory. The era of the individual miner, with his pick, shovel, and steam boiler, gave way to massive industrial dredges that chewed up the creek beds on a scale the old-timers could never have imagined. These dredges, some as large as a city block, could process thousands of cubic yards of gravel per day, extracting gold that the hand miners had missed. But the legacy of those early engineers of necessity remains, etched into the landscape and preserved in the ice. All across the Yukon, if you know where to look, you can still find the remnants of their work. Caved-in shafts, now appearing as deep circular depressions in the ground, mark the sites of their desperate winter campaigns. Piles of tailings, the waste rock from their sluices, still line the creeks in long, undulating ridges, visible from the air as scars on the landscape. And sometimes, when a modern mining operation cuts into an old hillside, or when a section of permafrost thaws and slumps away due to a changing climate, the work of the old masters is revealed. Perfectly preserved timber cribs, the spruce logs still solid and bearing their load after more than a century in the deep freeze, stand as a silent testament to the ingenuity and resilience of the Klondike miners. They are monuments to a time when men, armed with little more than steam, steel, and an unshakable will, built fortresses of wood deep inside the Yukon permafrost, all for the chance to strike it rich. Conclusion: the story of the Klondike timber crib is the story of a battle between human ingenuity and the implacable forces of nature. It is a story of how, in one of the most hostile environments on Earth, ordinary men accomplished extraordinary feats of engineering. They did not have degrees or blueprints. Their tools were crude, their resources scarce, and their margin for error was non-existent. Yet they learned to master the very properties of the frozen ground that sought to defeat them. They turned trees into fortresses, steam into a weapon, and the brutal Yukon winter into their most valuable ally. The gold they pulled from the ground made some of them rich, but the knowledge they gained, the techniques they perfected, and the structures they left behind are their true legacy, a testament to the incredible power of human innovation in the face of impossible odds. My name is Sam, and this is Wild America.